All right, welcome to SolidityATL's Web3 Security Session 6. In this agenda for this session, we're going to run through a few things. We have, ultimately, we're going to walk through a lot of attack vectors. So from this point on out, you're going to learn some more about various vulnerabilities. Hopefully, after you finish this session, you can get started in some audit contests if you want, finding some of those easier or smaller bugs. So, just to get started, Module 1 is going to have a quick rundown on logic errors as well as an example. Next, we're going to run through access control with another example. Module 3 is going to contain a little bit more about unchecked returns. And then lastly, we're going to finish off with understanding how to read an audit report. All right, so we're going to jump into logic error related vulnerabilities. We're going to talk first, what are logic errors and how can they be exploited? We're going to give a simple logic error example. After that, we're going to do a deep dive into a hack that actually was caused by a logic error. And then we're going to run through some common code smells you can use to detect various logic errors. All right, so what are logic errors? Similar to other programming languages, devs make mistakes, right? These can be caused by various different typos, incorrect assumptions, allowing state transitions into bad states, and then also incorrect math calculations. Logic errors contain any of these. It's essentially when a developer doesn't do something that they were supposed to do, and this can create an attack vector, opening them up into hackers exploiting them for these different vulnerabilities. So basically, it's when the logic is essentially incorrect, whether it was the mistake was small or whether the mistake was huge. So let's take a look at this example here. I'm going to give you, actually, you can pause the video now and just kind of read through this code before we run through it. So go ahead and pause. And as you're returning and you're looking into what this code is doing, you may see that it's something very interesting happening at this insurance ID at its status level. So if you notice, the funds is supposed to be unlocked, but it never actually is. So first we have a check to make sure it is locked, and then to unlock it, you may want to add, uh, you may want to make status equal false. But in this case, the developer accidentally did a comparison. So now we have is status equal to false, and that is just going to return a value that's not even checked, or it doesn't even matter because honestly, this is supposed to be uh, making the status be false, not check it. So this is a case where there's a logic error. The developer uh, accidentally made this, a conditional statement instead of uh, actually making this status equal to being false. All right, so we're going to take a look at a real world example where Chainswap was actually hacked for about 8 million, and this occurred, I believe, in late July of 2021. So let's take a look at this exploit code. And we have worked out a DeFi hack labs before, so if you want, you can look at the Chainswap exploit 2 contract. And just looking into it a little bit further, we can see the exploit that was actually used, or at least a simulated exploit that was used at the time of the attack. So just running through a few things. This is struct for the signature. This is Chainswap's receive function. I believe this is a factory contract function call that allows you to receive minted tokens, I believe, on um, the new chain, or at least on the receiving other end of the bridge. So if you need to, let's say, deposit some tokens or mint some new tokens, you would, let's say, burn them, and then you would receive um, your newly bridged tokens. So if I didn't mention already, I don't think I did, but Chainswap is a bridge, or was a bridge, and that's essentially how it works: is you burn some tokens of some sort, and then you would mint that token or representation of that token on the new chain, or um, whatever bridge you're using. So, and oftentimes you may do something like wrapped Bitcoin or wrapped Solana. So if you were to um, bridge to another chain, let's say I'm bridging from uh, an Ethereum L1 to Arbitrum, that's the kind of process that will follow. So if I was explaining it and you were trying to understand, well, what's a real world example? Chainswap, of course, is one, but think about Arbitrum. When you need to bridge USDC over, you have to go through a process where you burn the USDC on Ethereum's L1 chain, and then you mint some representation of USDC on Arbitrum. So what we're looking at here is the exploit contract, and in this case, this is the main piece you want to see. So as we can see, the exploiter created a new signature, used that signature, grabbed it here, and then used the signature, used an exploiter address to deposit funds into, and called this receive function. And the reason that they're doing this is because the Chainswap developer team had a logic error, and that error was, if someone has received something in the past, then they have already performed a successful withdrawal. So let's take a look at this line of code where the exploit was. So right here we see require received from chain ID, the to address, and the knots. Make sure this is equal to 0. And if it's not, that means it has been withdrawn already. But what the developers failed to check for, hence a logic error, is that you can create a new address, right? You can create a new externally owned account or contract address. This can be something controlled by anyone, a user or an attacker. So what the attacker did was bypassed this check by saying, okay, well, I'm just going to create a new wallet address with a nonce of 0 to allow me to receive the tokens I want. So this is what the attacker called when exploiting Chainswap for those millions. And all they had to do here was have some alternate logic to really validate that a withdrawal was already performed. Maybe not use something like the nonce of the address, but maybe have some internal contract logic that allowed you to actually determine if something had been withdrawn already. Maybe you have to use, a whitelisted or an allow listed address, or you have already used an address to initiate this process, and then you can receive. They could have determined however method would be the best way to remediate this, but at this point in time, they did not. They did not have the proper logic included in here, and the exploiter ran off with a few $1,000,000. So that's an example of a Chainswap logic error and how that resulted in this attack we see here. All right, so let's talk about code smells to help determine these logic errors. So a code smell is a characteristic in source code of a program that possibly indicates a deeper problem. Essentially, this is any time the code design violates traditional or fundamentals within a program or project. So there are specific rules that many developers follow, good ones at that, in terms of architecture, development, code structure. There's a lot that goes into the development process. And anytime that there's a variation from what is traditionally taught or is used as a standard, that's an easy way to determine if a logic error is likely included. So some of these, and this is not a comprehensive list, but some of these include lack of testing, very long functions, functions doing a lot of things, or just complexity in general. Another interesting code smell that I like to use is um, comments. If comments don't align with the what the code is doing, I already know that a bug is probably going to be included there. So that's example of different code smells you may develop over time, but these right here are ones that can help you easily determine if a bug is going to be there. Lack of testing. If a project has, let's say, 1,000 lines of code and maybe 2 tests, you already know there's probably an error or a logic error that they have included that they did not test for. Similarly with long functions, um, if there isn't a separation and organization of what the code should be doing, let's say you're supposed to compartmentalize some of the logic flows or the state transitions, and you don't compartmentalize those into separate functions, you probably have included a state transition that is going to have a logic error. And similarly with complexity and functions doing a lot of things, um, traditionally, if you are unorganized in your functions and you have, you know, so many different operations performing different things within one function, that is not following some of the principles that you learned in traditional development. One function should do one thing. It shouldn't be doing 5 or 6 different things all in one. So that can help you easily spot if there is going to be a logic error. And as you can see, when we take a look at the example we went over, there's a lot going on in this receive function. And you can see there's some areas where they maybe could have broken some things out. Or, like we said with testing, they did not test when someone created a new wallet. What happens in that case? So this is a great way to determine if you do have a logic error bug or you're going to run into some issues. Code smells are definitely your friend as a security auditor and a developer. Read more into code smells, ask us about it, but definitely have this in your toolkit when you are auditing various projects. All right, in Module 2, we're going to run through access control related vulnerabilities. So we're going to talk about what is access control and break that down for you. Then we're going to review various ownership checks and just a small example of what this looks like. And then we're going to take a look at a real world example where an access control vulnerability led to an exploit. And then lastly, we're going to finish off with some access control code smells that you can use to determine if a developer or protocol is missing access control. All right, so next we're going to talk about access control and exactly what it is. So when you have a protocol, different users require different permissions. A developer may require different permissions that an admin has. An admin may require different permissions that a standard user has. So what I like to ask when I'm reviewing smart contracts is, can a user perform an action they should not be able to? Can I, as a user with supposedly base level privileges, do something that maybe a developer can do? If that's the case, this is probably going to lead to some form of an access control issue. And so as you can see in this diagram, we have these admin roles. They're allowed to mint and create an NFT, and then the user role is allowed to buy an NFT. But if a hacker determines that there isn't the proper access control checks, that maybe as a user, you can do something the admin can do and mint or create NFTs at free will. we're going to look at incorrect ownership checks. So this still falls under the access control category, but this is just a way to find one of these access control bugs. So a permission function should have proper modifiers or ownership checks. If it doesn't, this is a great way for you to tell if there is a vulnerability. So let's take a look at this example. We have a contract owned. It has a variable for an owner. It has an owner being set to the message.sender in the constructor. So this essentially means whoever deploys this contract will become the owner of this contract. And then we have the modifier that says we want to check if the owner is equal to the message.sender. So the owner, which is basically the person who deployed this contract, is equal to whoever is sending the message or whoever is calling the function. And then here's the function in question. It's the transfer ownership function. So only the owner of this contract should be able to call this transfer ownership function. This is clearly a privileged function. A regular user should not be able to call this. Now, depending on the ramifications of this vulnerability, that can help you determine if it's a high, medium, or low severity bug. Typically, things like this will be high severity vulnerabilities, but that honestly just depends on the contract logic. Right now, with what we have that we're looking at, we can't tell exactly what is the vulnerability that's going to cause such damage. So basically, you have transfer ownership, but that can mean anything. Does this owner have the ability to view new functions, or do they have the ability to withdraw a large amount of crypto tokens? Let's take a look at the Melo token hack. This was a real-world example where the Melo token project was hacked because they failed to have the proper access control. You don't really need to know much about the project besides they were minting a token. Melo token was centered around being able to do gift giving and appreciation easily on chain. And unfortunately, they did not have the proper security controls to check for and proper access control. So let's just take a look at what the issue was and how the attacker exploited this. So I'm going to zoom in a little bit here, and it seems like they had a public mint. And as most of you may know, or as most of you should know, your mint should be highly protected. Only your admins or main developers should have the ability to mint a new token. Things can change depending on if you're implementing a bridge or not, but the idea here is you need to have access control on your mint. No one should be able to mint your tokens at free will, and that's unfortunately what they allowed. So when we take a look at the exploit, we can see that the attacker typed in exactly how much they wanted to withdraw or mint. They called the Melo tokens mint function, approved the router, and was able to swap these tokens. So that's essentially what happened with the attack. You can run this in Foundry yourself, but what you will find is that after the exploit, the attacker ran off with much more USDT than what they started with. Okay, let's look at the access control code smells. So if you're reviewing a protocol or you're developing a protocol, you need to make sure you have permission checks for various function operations. For example, when we talked about a mint function, you need to look at that function and just ask yourself, who all should be able to call this function? Should I, as the developer, be the one to only call this function? Should other employees within our protocol be able to call this function? Or should everyone be able to call this function? So these are just things you should be thinking about as you're building out a protocol. And then as security researchers, you should be asking those questions yourself as you're reading through smart contracts and auditing them. There may be a function that you believe should be protected, and you can address that with the developers or the protocol you're working with. Next is to make sure you can just test using these different roles. So, of course, code smell is when you're looking at a protocol and you're just reading the code and you can just sniff these out. But test is also a great code smell, in my opinion. If you read through a protocol's test, you can tell if they're even testing for these access control type of vulnerabilities, where you may have privileged functions and you may see that they only test for the cases where it's a happy path, where essentially if the developer or the privileged admin called this, it's supposed to do what it's supposed to do, but they don't ever test for those situations where a non-privileged user calls a privileged function. So these are just some code smells you can use as you're evaluating your protocols. And then again, as a developer, these are things you should be doing to make sure you're preventing access control related vulnerabilities. Now we're going to go over a more simple vulnerability called unchecked returns. So we're going to do a quick overview plus a small example, and then we're going to go over some common code smells to determine an unchecked return vulnerability. Alright, so an unchecked return is essentially when a function call or method doesn't have a check for what's being returned on that function call. So I know that's kind of a tongue twister, but if you have a function within your protocol, it may return a value, and some people don't check what that value is or evaluate if that value is something that's supposed to be returned. So let's back out of here and look at an actual example from an audit contest where two auditors caught an unchecked return. So we have, zoom in some. So we have this execute function which performs a call to an external target, and it looks like it just automatically performs the execution without a check of what's happening. So let's say this returns false, or this returns something that is essentially supposed to be evaluated, and that's what these auditors claim here, is that, as one can see, it does a call to the target contract with the provided call data going back to the vault controller. The success of the call is checked and reverts if unsuccessful. However, in one instance, this check is missed and could cause issues. So if in this function, this deployer adapter, we make some other calls, we do a decode, and then we perform this admin proxy execute. Well, it looks like this execute function is being performed, but there's no way to determine if this is actually a success or not. So you can execute something, it can return false, or that call could have been unsuccessful, and there would be no way of determining if that call was positive or not. So you would essentially be operating under the assumption that it's automatically executing, and that in itself is a vulnerability. So you should definitely be checking for these. This is honestly, I would say an easy grab me, or like a low hanging fruit, but honestly, a lot of auditors, as you can see, with all the auditors that participated in this contest, only two. There's a lot of findings from this contest. Only two auditors found. Yeah, look at that. Only two auditors found this vulnerability, and that's probably because people were looking for those higher level bugs, and they failed to find those lower level. Even this one came off as a medium, so things like this can cause issues. You must be checking for unchecked returns. All right, so let's take a look at some code smells for unchecked return vulnerabilities. One key code smell is just looking at a function and seeing if it ignores the return data from that function, whether it's internal or external. Another one is just lack of test cases around these edge cases of return data. So if you know that a protocol you're auditing has a few external calls, or let's just say it's using some function calls, if those test cases are not checking for the return value of these function calls, then you can already go ahead and tell that maybe what would happen if a value is something that they don't expect. So you can go ahead and create your own test cases yourself. But this is really important when looking for unchecked return vulnerabilities. Go look at those test cases, see if there's any edge cases around these return values, and think through them, create your own test, and you may be able to stumble upon an unchecked return vulnerability. In this last module, we're going to cover audit reports. This is one of the most important modules you're going to run through because it's going to show you how you need to read audit reports, why you need to read audit reports, and the benefits it can bring to your auditing journey. This is a crucial step in most people's auditing journey whenever they learn how to interact with other auditors' audit reports. So we're going to cover all of these today. Like I said, we're going to run through what are they, why they're important. We're also going to talk about how do you read one. And then lastly, we're going to finish off with an actual audit report read-through example. All right, so what are audit reports? A report of all an auditor's findings from a review or audit. This is essentially the report that an auditor gives to the client or the contest hosters whenever they have completed an audit. Some key things to point out for an audit: it typically contains a title, a summary, a proof of concept of some sort, and then a recommendation. And then the reason these are so important is because this is how you can communicate all of your hard work to the developers, the protocol who's hosting the audit, as well as the contest judges. In different cases, you're going to have different people reviewing your report. Like I said, you're going to have contest judges who review your report first before they hand it off to the developers themselves. And then with the protocol itself, you're going to have to write this in a way that the developers and the protocol team is going to understand what your problems are that you're finding, all those vulnerabilities you're finding. So this is why your audit reports are a very important step in the process of your audit, because this is how you communicate all of your hard work to these parties. And like I was saying, you're going to have different people who are going to be reviewing this. So you need to make sure that these reports are very comprehensive. They can communicate and be understood by anyone reading this report. It should be to the point where, you know, a middle schooler can pick up your report and understand what bug you're talking about. That's how you know you have a great audit report. So not only is this a great way for the protocol developers, the judges, to understand what you're trying to communicate, it's also good for when you come back to your audit and you need to understand the bugs you found. And this is also great for people learning. Whenever they're understanding and looking at other auditors' audit reports, it's best for them to learn with an audit report that gives very good examples. It gives a comprehensive description. It actually shows what the problem is at hand, and then also how to fix this problem. All right, so how do you read an audit report? As a beginner, you're going to want to start with findings that you understand first. I would honestly start with those informationals, those non-criticals, those lows, and those medium findings. These are findings that are pretty comprehensible and are usually easier to understand, especially if you have already spent a few months understanding Solidity, understanding how different dApps work. Another approach you can take after you hit this stage is to work your way up to more complex vulnerabilities as your knowledge grows. Just because we say you should start at the low and medium range, if you are a developer who understands some of these complex protocols, you could honestly probably start with more complex vulnerabilities. So that doesn't just mean you have to start at the base level. And also, it's important that you don't just read the report, you read the lines of code affected so that you can gain a deeper understanding of the problem at hand. Now, most audit reports are really great at explaining the problem and then how do you fix it. But honestly, you're going to get a better understanding if you kind of take a look at number one, the protocol that's being affected, skim through the developer documentation so you can have an idea of what the protocol is intending to do. And then when you go and look at the audit report and read those vulnerabilities, you'll have an even better understanding of why that vulnerability impacted the protocol and the way it did. All right, in this last slide, we're going to do a quick demo of what it should look like when you go to review an audit report. Now, just keep in mind, this is going to be a very shortened session of what I would typically do in a real world situation. It would take you a good bit of time to actually read through an audit report, but what I'm going to do is compress every step I would do whenever I'm going through an audit report. So in this example, we're going to use Llama Protocol's audit report. I think I already had it up. Okay. And so, like I said, the first thing you should do is honestly get a quick understanding of what this protocol even is. What do they do? So we're going to go to their main page. And you can see streamline on-chain access management. So they're dealing with access control and governance. And that should go ahead and just shift your mind into thinking, okay, governance related bugs, access control, we already talked about these things, so these are probably bugs that could be prevalent. That's cool. They have, a view of what using this protocol looks like, and that's honestly pretty cool. You can see what they do all in a matter of a few minutes of just staying on this page, so that's awesome. The next thing I would do is just go take a look at their documents. They have an awesome architecture diagram, it looks like. Oh, look at that. We have roles and permissions, something we've talked about. So that can already get you in the mindset of some categories you should probably go ahead and note down and pay attention to. I'm not going to go through note-taking just now, but if you do have some type of note-taking software you use like Obsidian or whatever it is, you might want to just jot that down as you're going to read the audit report. We have account logics, Llama executor, we have guards. That sounds like a privileged type of role. You have policy holders. Interesting. So we know this is governance. There's going to be some access control stuff, and I'd probably read through this introduction section, but I'm not going to do that here. That's something you can do on your own time. So, like I said, that's just the first part. Get a good feel of what Llama Protocol is. I know I sped through that very quickly, but that's essentially what you would do just on a larger scale. And we are on Code for Arena, so this is how they structure their reports. We don't really have to go through the overview and the wardens that were part of this. Maybe the scope would be good. I don't know if this is still going to be shown, but okay. Interesting to see what this scope was all about and maybe what contracts were even audited in this. Yep, okay. Cool. So let's just go back and take a look at these findings. So as we talked about, you have your title, you have a description. Usually you have, so you have your title. Don't know why they don't really have a description here. Okay. So you have vulnerability details. So yeah, you have your title, your description, which in this case is the vulnerability details. You have a proof of concept, which tells you how does this, how can this attack be performed in the wild. Then you have your recommended mitigation steps, which is how do you fix this thing, and that's it. That is essentially your audit findings. And so we see that this is a high severity finding for someone who is newer or may not have the development experience. This may be a difficult finding for them, but let's just take a look at it. So In Llama relative quorum, the governance result might be incorrect as it counts the wrong approval disapproval. Okay, so I don't think this one is a pretty difficult one to follow. But again, I've audited it before. I've been in the space for a tad bit. So just reading this title, I can kind of see what this vulnerability is going to be at. This just incorrect counting. I don't know if it's incorrect math per se, but it's incorrect tallying of something, and this can cause issues down the line. So what you would do next is read into this, read the whole finding. Look at the code a little bit. So I would honestly click in, read through this code, and kind of just understand what function is around this, and understand, oh, get approval quantity at, and kind of understand what this is. Like, if you don't understand this audit report, that's the kind of how you would approach this problem. But if you understand the audit report, you can understand this, jot this down in your notes, and then use this and kind of just store this in your brain when you reach other contests that maybe have some governance type of functionalities within it. So let's see if we can understand it now. So the governance would be the wrong below. There are 3 role holders, and Alice has 2 quantities, others have 1. During the action creation with the Llama red corner strategy, 2 proposed at least 1. Okay, so basically someone will be able to approve something, and this is a governance contract, and that is a pretty big issue, which is why I see it's a high. Someone will be able to approve something with just only 1 approval, and it seems like it's not meeting the full quorum of approvals that is needed. So this is cool, a great finding, a great write-up. They have a good POC, and they made it possible to understand this by marking where all of these vulnerabilities lied, where all those issues lied. You can see, another good thing about some of these audit contests is you can see the judges disputing as to why, and then you can see, this is the Llama disputed. So you can see where the developers may dispute this, and then how the judges go to say this is actually a valid finding or not. So this is what I would do. I would just go through each of these audit reports and get a feel for what the title is, what is it explaining, how are they explaining it, and then what is the fix for it. And this is great for you because once you figure out the format, you will learn how to write your own audit reports, how to generate your own findings, and how to make them so great that they are the best reports. Personally, just as a quick tip, I'm not saying use ChatGPT or AI for your audits itself, but for the language, for the grammar, it is a great tool to use because they can read other audit reports and kind of help fine-tune the language for you if you have a struggle doing that. And then also, if English is not your first language, I don't think this is something that's talked about, but if English is not your first language, AI can be a great tool in helping you find those errors and make those corrections where you wouldn't be able to explain it, appropriately in English. We don't want, your language barrier to be the reason why your finding isn't submitted or why your finding isn't understood. So definitely leverage tools out there, AI models, to help translate these things in a way that would be best to be communicated to someone who is a native English speaker or someone who may be reading this audit report. So yeah, like I said, this is what you would do. You would make sure you have your title, description, nice POC, and some recommendations. And for those of you who are beginners and you are unfamiliar with these reports and trying to understand these findings, we can scroll down to these gas-related findings. These are much easier to understand, as well as these non-crits findings. So let's see. Initial value check is missing in set function. There you go. So there's no initial value check there. easy one to find. Use inherit doc rather than using the non-standard annotation. These are great findings for you to understand just those lower level bugs that still provide value to a contest and to developers, but it may not just be one of those high severity, really impactful vulnerabilities. Look at this one, a low inconsistent documentation of actual function logic. This got someone paid. An unbounded loop. It's a low. A missing contract existence checked before low-level calls. That's a low. So you can see where these low-risk and non-critical issues are a great place for you to start if you are having issues understanding what's going on. And I guarantee you, these people who are submitting these, they may not be at the level where they're submitting the highs just yet, but with months' time of practice, training, I guarantee you'll see them at the top of leaderboards if they aren't already. Because I think Llama is it's an older report, not too old, but yes. So that is how you would essentially go through an audit report. We saw that when we first started. We looked at the protocol to understand what it's doing. I may look at the code a little bit as well and just skim over what's happening. And then after that, I'll read through the audit reports and start categorizing these findings into a way where in the future, if I'm auditing another protocol that deals with governance, I can look back at my Llama notes or just look back at this audit report to see where similar vulnerabilities could possibly be found.